So, we are going to talk about jet streams. What are jet streams? So, they are strong, narrow winds in the upper troposphere. According to WMO, World Meteorological Organization, it defines jet streams as a strong, narrow current concentrated along a quasi horizontal axis. Quasi horizontal is not completely horizontal, it means wavy. In upper troposphere or in the stratosphere, characterized by strong vertical and lateral wind shear. Wind shear is the rapid change in wind velocity or direction and featuring one or more velocity maxima. So this was about jet stream. That what is a jet stream? It is a strong narrow current in the upper stratosphere. I am giving you a small example that during the World War II, the aircraft was moving from USA to Japan. When it was moving from USA to Japan, it took very less time to reach to Japan. But when it was returning back, the time taken was more. Then it was observed that when the aircraft was moving from USA to Japan, then it was moving in the direction opposite to the jet streams. And when it was returning back, it was moving in the direction parallel to the jet stream. There it was observed that when we move in the direction opposite to the jet stream, the time taken to reach the destination is less. But when we move in the same direction along with it, the time taken is more. Because of this, the aircraft they either travel below the troposphere or below the jet streams or above that. Okay, so next we are going to talk about the different characteristics of jet streams. So the first characteristic is they are thousands of kilometers in length. In length, they are of thousands of kilometers and few hundreds of kilometers in width. And they normally blow from west to east, as you can see in the images. They are stronger and faster during winters. So during winter they are stronger and faster. The entire system follows the sun. The entire jet stream pattern, it follows the sun. As the sun changes its direction, the jet streams they also change their directions from north to south. They follow zigzag path like Rossby waves. Rossby are the not the horizontal, but they travel in a wave. Next, we are going to talk about the formation of jet streams. The temperature difference between the two regions, that is the tropical and polar, or it can be maritime and continental, means land or the ocean, results in difference in pressure gradient with altitude above air pressure. The temperature difference between the two regions, either it can be tropical and polar or maritime and continental, it results in difference in pressure gradient with altitude above the air masses, which results in strong winds between the two regions. And larger the temperature difference, stronger will the winds. Next, we are going to talk about the types of jet streams. So there are 5 types of jet streams: polar front jet stream, subtropical westerly jet stream, tropical easterly jet stream, polar night jet stream, also known as stratospheric subpolar jet stream, and local jet stream. So one by one we'll see that what are they. First we'll talk about polar front jet stream. So it is formed in the regions where temperate and polar air masses interact. They are irregular and discontinuous. They blow from west to east along across the globe. Second is the subtropical westerly jet stream. So they are associated with temperature gradient at the poleward limit of Hadley cell. They are associated with temperature gradient at the poleward limit of Hadley cell. They blow from west to east all across the globe and they are more consistent and strong. Okay. Third is tropical easterly jet streams. So they are formed over India and Africa in summers due to intense heating of Tibetan plateau and the desert. They blow from east to west. They are associated with Indian monsoon. Fourth is the polar night jet stream or the stratospheric subpolar jet stream. So they are above the troposphere over the polar region during the winters and they blow strongly from west to east and confines the cold and dry air of polar regions within the poles. They are also associated with formation of ozone holes. Fifth is the local jet stream. So they are formed due to the local thermal and dynamic conditions. Example is the Somalia jet stream of the coast of East Africa. So next we are going to talk about the significance of jet streams. So jet streams, they help in generation of cyclonic and anticyclonic circulations on the surface. Let's see what are cyclonic and anticyclonic circulations. So as you all are seeing on the screen, the air above the atmosphere and the troposphere, it is confining. Okay? The air is converging. This converging air, it causes the air on the land to diverge, and this leads to the formation of anticyclonic circulation. And the air in the atmosphere which is diverging, it sucks the air which is on the land. This leads to cyclonic circulation. So this is what is anticyclonic and cyclonic circulation. All the air, all the pollutants which are on the land, it is sucked by the air which is diverging in the atmosphere. Second significance is they affect and change the local weather conditions. Third, they help in transportation of pollutants and its dispersal in the regions where there is an accumulation of higher quantities of air pollutants and particulate matter are there. They help in the transportation of pollutants. They transport the pollutants and its dispersal in the regions where there is an accumulation of higher quantities of air pollutants and particulate matter. Next, they help the movement of aircraft in upper troposphere and also save the fuel. It helps in intensification of temperate cyclone. Monsoon of South Asia is controlled by subtropical westerlies jet stream as well as tropical easterlies jet stream. So we are going to talk about air mass. First, let me clear you something that air column and air mass is different terminologies. They are absolutely different terminologies, but most of the time what we do, we that use it for the same same purpose, like air column and air mass, we consider it at the same, but it is not same, they are completely different. So what are air mass? Air mass, and they are the section of atmosphere with a uniform characteristic of temperature and pressure. In this, the temperature and the pressure is uniform, not throughout the surface, but to up to some extent it should be uniform. So what are air masses? Let's see. Air mass, it is an extensive portion of atmosphere whose physical properties such as temperature, moisture, lapse rate is the rate of decrease, and humidity are homogeneous. Homogeneous means uniform. For both horizontal and vertical direction, it should be uniform. Next, we are going to talk about the characteristics of air masses. So first characteristic is the source mass should be uniform and homogeneous over a large surface. For example, an extensive desert region or an extensive open ocean surface or a large plain region. So at such places, such surfaces, the air should be uniform and homogeneous, then it will be considered as a air mass. Second point is winds should be light and divergent. The wind should be light and divergent, which and divergent wind, such type of wind, they exist mainly across the high pressure belt with anticyclonic circulation, which results in stability. So where there is a stability, there will be formation of air mass. Third is the temperature should be uniform in horizontal direction with very gradual change in vertical temperature. Means the temperature should be uniform. It should be not be changing in horizontal direction with very gradual change, but there can be some gradual change in vertical temperature. Fourth point is the humidity should be uniform with very less variability in moisture content. Humidity should be uniform, but there can be very less variability in moisture content. There should be not more large amount of variability in the moisture content. No, it should be very less. Next, we are going to talk about the classification of air masses. So they are classified on the basis of their source, temperature, pressure, and latitude. So on the basis of the source, they are continental air masses and maritime air masses. On the basis of temperature, there are warm air mass and cold air mass. Pressure, there are stable air mass and unstable air mass. On the basis of latitude, there are Arctic air mass, Antarctic air mass, polar air mass, tropical air mass, and equatorial air mass. Next, we are going to talk about the significance of air mass. What are the significance, importance of air mass? So first significance is that the air masses, they transport heat from one region to other, and they help in maintaining the balance in global temperatures. Second is the maritime air mass. They bring more moisture towards the continental region, increasing the humidity over the continents. Third is the interaction of warm and cold air masses in temperate regions lead to the formation of fronts and temperate cyclones. So let me give you a brief introduction of front. So front, front, they are the boundary where two different type of air mass meet, and these fronts are the zones where temperate cyclones are developed. And the maritime air mass in the Indian Ocean, also plays a very important role in bringing good amount of moisture to India and South Asia. Also, they bring good amount of precipitation to Indian monsoon. ठीक है. Next point is the maritime air mass of Indian monsoon. It affects the amount of rainfall in India and South Asia through through Indian monsoon as well as through tropical cyclones. The dry air mass along the subtropic results in arid condition. And the last point is the cold air mass from Siberia affects the temperature of regions for a long distance and causes cold conditions during winters. Next, we are going to talk about temperate cyclones. In this, first we'll talk about the fronts. So, I have told you that fronts are the boundary where two different type of air masses meet. So the cold air mass meet with the warm air mass. So cold air mass, they occur near to the polar regions where temperature is down or less, and warm air mass, they occur near the tropical and equatorial regions where the temperatures are high. There is a term known as frontogenesis. So, frontogenesis is the process which is involved in the formation of front, and frontolysis is the process where the front decays, it disappears. ठीक है. So if we talk about the region where we can see more fronts formation, so they occur across the mid latitudes where the cold air masses from polar regions, they meet warm air mass from the tropical region. So the warm air, they are the lighter ones, so they are always above the cold air mass. So fronts is a narrow zone of transition dividing two air masses of differing temperature and humidity characteristics. Temperate region is the zone of interaction of two air masses, and the fronts are commonly developed along these mid-latitude regions. The process of formation of fronts is known as frontogenesis, and the process of decay of fronts is known as frontolysis. Next, we are going to talk about the warm and cold front. So, warm front are the boundary between warm and cold air mass, where the former is advancing and overriding over the cold air mass. In this case, the warm air is advancing over the cold air mass. The gradient of front is gradually leading to slow ascent of warm air, resulting in stratonimbus clouds, resulting in the formation of stratonimbus cloud and steady rainfall over a larger area. There is a steady rainfall over a larger area. Next, cold front. So it is a boundary between warm and cold air mass, where the cold air mass is advancing. In the previous, the warm air mass was advancing and undercutting the warm air mass. This results in a steeper gradient along the front, leading to rapid ascent of warm air and cumulonimbus clouds. Cumulonimbus clouds are formed, which results in heavy rainfall over a smaller region. Here, heavy rainfall take place over a smaller region, and there's steady rainfall over a larger area. Next, we'll talk about occluded front. It is the later stage of front formation where the air in warm sector is no longer at the ground surface. It is a compound zone with warm and cold front characteristics. ठीक है. In this case, there is no air which is for a longer time at the ground surface. Last is the stationary front. So it is a type of front where the two air masses are unable to push each other and the position of front does not change. Once it is disturbed, it leads to warm or cold front. So in this, what happens, the two air masses, they are unable to push each other and the position of the front does not change, and once it is disturbed, it leads to warm or cold front.